Yes, it's been slightly stressful, so if I make any mistakes, please excuse me for that. But we'll do what we can here. All right, so let's talk about assignments real quick. Fairly consistently, I've been receiving assignments past the date that I set for feedback. I want to reiterate, talk about that for a second, that only except for one condition and a couple of okays I said last week, will I be looking over assignments if you passed them in past noon on Sunday. I don't have that much time on my hands outside this class, and I can't be looking over assignments too often if you send them in late. So if you pass them in past noon on Sunday, chances are you're going to get a one-liner from me saying this is wrong or this is right, and go fix it later or not. That's about it. The only exception here is if I've given an incredibly difficult gamma assignment, in which case you pass it in before the due date, but after the feedback time, I will look it over. In this case, this was one of those weeks where I thought I put too many things in it to make it too difficult to do. Some people did it. So, props to those who did it or tried to do it. I will still look over your assignments. Was that a question?
So if we don't finish it in time for the feedback period, but still finish it like before the class, or at least, should we still send something in? Or?
Yes.
Right.
So if this is the case, if you can't finish the assignment before the due date, you should have started it earlier, that's one. But assuming you did start it earlier, you still can't do it. Maybe you've asked questions, maybe you haven't. Pass in what you've done, and I can critique you on that. If you keep trying to extend it past that, maybe you're like, I'm going to pass in a C out, and then he's going to look it over, and then I'm going to pass in the rest of the next 3 days. No, it doesn't work like that. But I will look over what you've done. If you have a half finished, if you finished like 90% of it, minus a little part, or maybe a small, maybe a full section, I will look it over. You can redo that part, and I will do that. It's just I don't have time to be getting these assignments after the day for feedback because I've set an allotted amount of time on Sundays to look over assignments, and I don't have time to put in so much outside of that amount of time. Okay, is that fair? I don't care. It's my rule. Anyway, also don't forget, send me your thing, or you don't need to send this. This is if you want to change it. You can change it to whoever that says there. Fine. Any questions? So let's talk about assignments. Are there any questions about the assignment that we want to go over? No? Or get to you later. All right, so let's roll. Let's go straight into this. We're going to talk about the STL today. More specifically, we're going to be, let me see right there, it's the STL. It's part of the STL. It's a little bit. We're going to talk about the STL, and in particular, we're going to be talking about vectors and arrays, and why arrays are bad. Okay? So, start. Arrays suck. They're terrible. Oh my god. Anybody who's working in C here? Yeah. People know. Working with arrays, they're terrible. Alright? Maybe you're like, oh yeah, but the general array is pretty good, but you're wrong. That's because the basic array we're talking about right here is just bad. Look at that. That's a terrible array. You see, this is a mouse. This is a type. This is an array. This is the box. That's it right there. It's disgusting. Look at that. Ew. Oh, it's terrible. Can't resize that thing? Not at all. Bit operations can be unsafe. Maybe you're adding to it. Don't do that. You might lose the head. Size has to be known at compile time. It's not dynamic at all. It's just disgusting. Oh my god. It's terrible. For those who don't know what arrays are, let's talk about that real quick so I don't lose you. You're storing with, if you're talking about types, maybe you're working with an integer. And see. And you want that integer to equal number equal to 5. That's fine. That's perfectly fair. But let's say you're working with a list of things. You want all the numbers from 0 to 5. For you math fellows out there. Kind of like 0, 5, and something like that. I don't remember. I do some issues. What an array would be, you would have a list of these numbers, and they would go from 0 to 5. In this case, with this disgusting thing right here, you do int, and then you do the name. We'll do numbers, nums. You do these two brackets. You don't need to write this part down. This is not what we're going to be working with. Just so you can understand, equals, oh sorry, just do 5, I believe. And then you would just do, sorry, 6. And then you would do, you could set each one on its own, or you could set it up to that. So then you would eventually have a list of 0, 1, 2, 3, 4, 5. Okay? You'd be able to work with this list. And if you want to access things here, in this position right here, you could access it by, we'll get to that in a second, don't worry about that. An array is a list, all right? This part is slide in the following slide are mostly for people who know C. Pointer arrays suck too. In fact, these may be even worse in some ways in C. So look at that, that's terrible. It makes me want to cry. Or C++, the version right there, look at that. That's how you do it in C++. These are bad. Why are they bad, Darian? Why are you yelling at me? I just came to class, I want to learn. So this is because they require manual reallocations. They're dynamic. You can resize them on the go if you want. The problem with that is that they require extra work to resize. You're busy people. You only have so much time to resize these arrays. You don't want to be doing that. Why would you want to do that? It's slow too. Plus you need lots of boilerplate code for dynamic resizing. If you're going into computing 3 next semester, which I know some of you are, you're going to have to do this assignment where you make your own dynamic arrays using this stuff. You're not going to like it because it requires some boilerplate code. You're going to see the following solutions that we get into. This is what you're going to want to look at, all right? But life can be better, all right? So, the STL is really cool. Where do I put this? The STL is really cool. What the STL is, I need to erase this. The STL is a standard template library. Standard template library is made by a bunch of people who are smarter than all of us, myself included. And what it is it's a bunch of functions and a bunch of data structures that you can use that go about just having all this boilerplate code done and written in the most efficient possible way that you can use. So let's say you want to make a list of things, like this array right here. There's a better way to do this. And what is this better way? We're going to talk about that. These are called vectors. Oh my gosh. If you're in physics, it's not that kind of vector. All right? Let's talk. This is how we write a vector. We include vector. We're using std, : vector. Here's our main function. There's a vector. And there you go. We just put 10 in the back. Why is this better than a normal array, Darian? This looks like more writing. Well, let's talk about why it's better. So, for those in C, you know that a normal array, like this, you have to have the size created at runtime. The size of it can't change, period. End of story. Sorry, not runtime, at compile time. End of story. You can't change that. And if you're working with a pointer array, you have to manually reallocate this thing over and over again if you add more stuff. Plus, then you have to see size of if you want to see how big it is. There's no easy operation to get all this. There isn't type safety. There's a lot of stuff that's just bad. So why is a vector good? Well, for those who aren't in C, you're not going to understand the pains of this. But when you're working with this stuff in C, you can only have an array that's so big where it takes a lot of annoying operations to make it bigger. This right here, or smaller. This right here is a dynamic array. As you add things to it, it gets bigger. And it's done in the most efficient way you could possibly think, at least for this single data structure. If you know data structures, there are other better choices in some cases. You don't need to worry about that too much right now. So what this does is it simplifies your life. There are a lot of really helpful functions that come along with vector. You can see how big it is. You can see what the last element is, what the first element is, what the middle element is. You can iterate through it. You can filter items in it. You can do lots of, yes?
Can you do a vector of strings?
You can do a vector of strings. You can do a vector of your custom object called dog. It doesn't matter. In fact, you can even do vectors of your base class and cycle through them. For those who did the Gamma assignment, you know what I'm talking about. Maybe to a degree, maybe not. I don't know. Anyway, so that's your vectors. These are exciting because they make your life much easier. For those in C, you know what I'm talking about. For those who've worked with Java, this is sort of like an array list. And for those who've worked with neither, just know these are what you're going to want to work with. This is nice. Okay? But why is this? Oh my God! They're dynamically reallocated. I just talked about this. They're super efficient and fast. I just talked about this. No more boilerplate code. I just talked about this. So much functionality for free. I just talked about this. And such fast, very speed, much easy. Yes. Okay. Yes.
Question. What do you mean by boilerplate code?
Okay, I'll go over that real quick. So, let's say I'm going to open some random file. Doesn't matter what it's called. We'll call it. Actually, we'll make a quick class. So ls, and we're going to go into src. I'll learn how to type again someday. And we're going to make. We'll just do food again. Food.cbp. And we're going to go into include and food.h. Please note I'm not using capital letters for these classes. I should be, but I am not. And hey, get back here. This is definitely commands. Cool. And let me just close these other files that were from last week apparently. And not have Sublime freeze up on me. One more time. You can do it, I believe. Is it seriously going to freeze up on me? The fastest application in the entire world? No. Okay, it is. We're good. We're going to make a class real quick. Okay, let's make a class. Class called food. And then we're going to write a getter. This is just going to be pretty similar to last week. Private. And we're going to have bool. And this is going to be is cooked. Now the thing is with classes, chances are you're always going to have a getter. You're always going to have a setter. Void get cooked. We'll do is cooked. No. Get cooked status. And then we'll do void. Oh, this is going to need to be bool. And we're going to do a void here and set cooked status. Okay, and this is going to take a bool, and it'll be cooked. Okay, that wasn't much work. But let's just imagine right here, that get cooked status is an incredibly complicated function. It takes lots of work. It would be great if what you've done here in get cooked status wasn't a lot of work to write. In fact, it's something that's easily repetitive, that people have made before in the past, that you could just use that code for. So, this is a poor example, I guess. But let's say, let me write it on the board real quick. Let's say we want to get the size of an array. In C. To do this, you need to do size of, and this is not perfect, in some cases it will fail, size of, and you do the array, we'll call this array, and then times the type, int, maybe. This is the idea. You get the size of the array, and then you multiply it by the integers, by the size of an integer. Size of integer. Something along those lines. You can see I'm already messing up here and there too. This is sort of boilerplate code. This is something that someone else can easily write that's been written before in the past. And why include writing it if someone else has done it and has done it better and is going to do it without an error? So the idea behind boilerplate code is if someone's already written it, the idea behind boilerplate code is that it's just code that you're going to write every single time. And you don't want to write something every single time. The point of coding is to get things done easily and fast, so you don't have to repeat yourself. With the STL, you have functions like size already predefined, so you don't need to worry about that. People have already written it better than I have, and it's already been done. Okay? Does that answer your question? Did I jump around too much? Are there any questions about what I talked about? Did I jump around too much? I think think I did. It's okay though. Yeah, there's Doge. So let's do an example real quick so everyone can see a vector in real life. They're very rare. They're like that holofoil card that you were lucky to get if you bought all the expansion packs. They're actually not. You find them everywhere. And let's close this. And I'm just going to remove the file I just made, arm food, and cd source. And now we're just going to make a main function, main.cpp, main. So, to work with a vector, how do we start? What's the first thing we do? Does anybody know? I did kind of fly by it.
Include vector.
Oh, that's a great start. This part's optional. We'll include it anyway. std : vector. Yes?
Could you also say using namespace standard?
Yes. Talked about this in an earlier class, but I did kind of breeze through it. Using namespace std, using namespace standard, is something you can do if you want to make it so that you never have to include this for anything. What's the problem with this? Well, let's say, I use an analogy for this. Talked about building a table. Let's say you want to know how to build a table, given the instructions on how to build a table. All right? You buy this table from IKEA. You could buy it in a full set too. You could buy a table, you could buy like 16 chairs, you could buy an oven, maybe 2 ovens, and a stove. And there are instructions for all of these. When you use something using namespace standard, what you're doing is you're including the instructions for all of these, every single one. When really, all your code cares about is just this one thing, vector. When you do something like this, now you have included all of the manuals, and you're going to make your code needlessly slower, when what you could really do is just this right here. In addition, what's worse about using namespace standard is that if you are to do it, if you have your own custom library that uses std : which you may find in certain industries, what happens is that your code is going to be incompatible with your custom library and the standard template library at the same time. And this is going to create some awful incompatibilities. When you go to Computing 3, your teacher's probably not going to care, and you'll probably be allowed to do using namespace standard. Just know, isn't the best practice, and using individual ones on their own is very handy, and it's usually what you should do. There are some exceptions. If you're using C++ 11 and you use the chrono library, for example, using std : chrono, std : whatever, inside a function is very annoying. And you, instead of using a global namespace, you can use a local namespace. And you can do it here. And then, using namespace standard is only in that scope. It isn't anywhere else. This is more okay to do. But if you use a global namespace up here, you're not necessarily asking for trouble, but what you are asking for is possibly trouble. It could happen. I always say to be wary of it. You can do it in my class, that's fine. I won't be sad, but you can. But, sorry, but I would recommend not. There we go. Anything else? Any other questions? No? So let's make a vector. All right, so I'm going to do vector. And this is how we start every vector. Then we do these things. Still don't have a good name for them. We do the triangle bracket, and then we need the type of what we're putting in here. So we can't just have a loosey-goosey vector that holds anything. It doesn't work like that. We just say what we want inside our vector, so the compiler knows beforehand what's going to be put in there. In this case, we'll just use integers. Int. Now we need a name for it. We'll call it din array. And we're done. Sorry, and we're done. Now we've created a vector with a default constructor. It has nothing in it though. Let's just compile this real quick, just so we know it works. Make and cdbin / hello world, and it prints absolutely nothing, and it should print absolutely nothing because we've done absolutely nothing yet. Cool. Let's go back and make it do things. Now, you're probably asking, but Dari, I've worked in C before. If we have an array of size 0, you can't do anything with it. But you can, because this isn't an array. So, there are functions in vectors that allow you to add things to your array regardless of the size. One of them is called push back. So, if we do din array dot push back, and we can put any number in here. I'll look the number 42, the answer to life, the universe, and everything. Now we've added the number 42 to our dynamic array. What does this do, Darian? I want to know. Well, when you have an array, let's make an array. This is actually going to be a vector. From here on out, if I say the word array, unless I specify it's a dumb array, it's a vector. Let's say I have an array, and it's got 1, it's got 4, it's got 9, it's got 42. And, no, it's got 7. And I run this operation right here, push back. What this does is it just appends the number to the very last item here. That's it. What is this really doing behind the scenes, though? What it's really doing is that it's doing a lot of heavy lifting for you. You don't know C too much. You don't need to worry about this a lot. I just want to talk about really quickly about what's happening behind the scenes. Because for those, this is applicable to even those who don't know C. What it's really doing, this is a vector, is that when we have an array, we'll make it a vector. Vector, and it'll just be like this, int, and it'll just be like this, then array. But this one already has the size of 4. So what it's done is it's allocated space for 1, 2, 3, 4 numbers. All right? When we add a 5th number to that with push back, what it does is it reallocates. It makes it twice as big as it was before. And now we have 2, 3, 4, 5, 6, 7, 8 spaces, even though we only have 5 in there. For those who have done C, you know this is an expensive operation, and it costs a bit of time. For those who haven't done C, this is a little bit intensive, and you don't want to reallocate more often than you have to. You don't want to constantly be adding and making the thing bigger. So, what happens here, if we know that our vector is going to be larger or smaller, we can make it a set size beforehand. And we can do this using the non-default constructor. If we know that our vector is going to be approximately of size 20, we can set it to size 20. And it'll only grow as it gets bigger. This way, we can make our code faster if we need it to be, and if we don't care, we can just remove it like that. This is just optimization, and it will work regardless of whether or not you do this. Yes?
If you made it like size 20 and you wanted to make it so it had 21, would it have 40 slots then? Like 40?
Yes, it has 40 slots. Any other questions? Yes?
So it does double, it doesn't increase by a third?
It doubles, that's correct. Every reallocation, it multiplies its size by 2. This is the fastest way to do it, at least that's been decided. This brings the idea behind size and capacity. Don't worry about this too much yet. The size of a vector are the number of elements in it. The capacity is how far the vector has expanded to. So if it's doubled in size, because we just added a 5th number to this, the capacity will be 8, but the size will be 5. Yes? Is that a question? Okay. Don't worry about that too much right now, though. That's just a quick optimization thing. Now, once again, for those who have worked with arrays, would you mind telling me how you go about getting a number in an array? Go for it.
If the array is big enough, you go to the size of element and stick your item in.
Yes. Good. That's the idea. Well, we're pulling it from it. We're not writing to it, but that's the idea. So for those who haven't worked with arrays before, the idea behind an array, we'll make another one. This is the same with a dumb array. Random numbers. 4, 1, 43, 4, 5. Is that you get these numbers at a 0 index, which means you don't start counting at 1. Start counting at 0. Okay? So if you want to get this 4, you're not pulling from the first element. You're pulling from the 0th element. And if you want to get this 1, you're not pulling from the first element. Sorry, from the second element, you're pulling from the first. And if you want to get this 5, you're not pulling from the 5th element, you're pulling from the 4th. Does this make sense to those who haven't worked with arrays before? Are there any questions? Okay. Know what the people who have made arrays done is they've used overloaded operators. Don't worry about this too much yet, but know that this makes your life a lot easier when you're working with vectors. So let's say I want to get this number 42. We know that it's of size 0, size 1, it has one element in it, 42. And we just want to pull that number out. So what we're going to make an integer. And we're going to call this num 42. Does that have a unit? It has a unit now. Num42 equals din array. Look at that. 0. But Darian, this is weird. It's not a dumb array. I shouldn't be able to do this. But you can. And we'll talk about overloaded operators in another class. But just know, to get an element there, you use the 2 brackets, and you put in the number where it is. That's one way of getting these. There are other methods, that allow you to pull from this array, from this vector. And they're a little bit safer, but for now, we're just going to use this way. And then we're just going to print this number. I need to include IOStream. And using std_cout, using std and Lowell. And we're going to print and num42 and Lowell. And this is our number. Look at that. Beautiful. Let's make this. There's our number. Look at that. That's 42. We pulled this straight from the array, from the vector, right there. So, once again, what this did, we have our array. We have number 42. We pulled from the 0th element, and we got it. Is this confusing? Does anybody have any questions? No. Good. But we can do better. What if we wanted to add bunches of things to this? And then we want to loop through it. This works very similarly to if you had a standard array. So we would use a loop, we would go through based on the size, and then we would just keep going until we hit number 1 less than the size. So we'll hold off on an example for now. Let's go back to the slide. Example time. No, I don't have any animations. Oh, that's no fun. So other uses of the standard template library. For those in computing too, there are a lot of things that you had to build on your own that are pre-made in the standard template library. You have hash maps. Hash maps are, if you don't know what they are, you don't need to worry about them. So you have hash maps, you have your queue, your priority queue, double-ended queue, you have a stack, you have a set. All of these are pre-built for you in the standard template library, which is great. That saves you a lot of work, and they're written in some of the most efficient ways that you can think of. Some would argue that there are more efficient ways. If you use the Boost library, that's going to be more efficient in some ways. But standard template library, it's a very good sort of catch-all in order to do all these. Awesome. Well, I don't have animation on this one either. Oh, I was slacking. other things you can do with the standard template library, and this is helpful for those who haven't even worked with C. You can sort your numbers or anything in your data containers. You can determine if it's sorted. You can merge two vectors together. You can do multiple types of searches, binary search, quick search, stuff like that. You can do if all the items in a vector are there, you can see if that's true, or if any of them are there. I already talked about finding a search. You can replace items in there, and you can even rotate your vectors. So if you have a 2D vector, you can switch it like that. We haven't talked about 2D arrays or vectors yet, but just know that you can do it. You have that power and you have that freedom. All right? Okay. Hey, get back here. Oh my, get back here. This is terrible. My PowerPoint thing is just not agreeing with me. I'm gonna go back. So, I think, actually no. No, we're probably good with that right now. So now, let's do a quick prototype of the alpha assignment. Some people are still a little shaky on this, and I want to go over it quickly before we go, well, not necessarily quickly, enough time so that everyone can answer questions, and I can answer questions about it, so we all know what we're doing for the assignments. All right, so let's build this real quick. In fact, better yet, let's get the assignment so that we can all see what it is. And OneDrive stole my Alt-Back keyboard shortcut. Fight me, Microsoft. Okay. Here it is. What is the assignment? It's called Crazy Shapes. Check out this crudely drawn UML diagram. It's so crudely drawn. This arrow is not even pointing to the center, and this one's off target. Look at that, that's silly. That's how you know I made it quickly. But that's regardless of the point. It's a cool assignment. What we need to do is we need to make some data structures that look just like that. So if you remember our classes in our inheritance, this is pretty much what we're going to do. We're going to make shapes, we're going to make 2D shapes, we're going to make 3D shapes, we're going to make squares, circles, cubes, and spheres, and they're going to inherit from each other just like that. Nice. Let's get to it. All right? So I'm going to clear out what I just worked on. All right. And one more back. And ref source star, include star. Yes. Yes. All right, let's go into include. And what we're going to do first is we're going to make header files for all of these shapes. I'm also going to move this down here. Good. We're going to make header files for all of these shapes. We're going to make one for shape, 2D shape, 3D shape, square, circle, cube, and sphere. So let's do that right now. Subble, and we're going to do shape.h, square, 2D shape.h, 3D shape.h, 4D shape. Then we're going to do square.h and circle.h, and we're doing, what are the last two? Cube and sphere. Cube.h and sphere.h. Nice. Let's also have C++ files for these too. And CPP 2, 3, 4, 5, and this last one. All right. Now we have files for all of our stuff. And there are plenty. Are there any extras? I don't think so.
Do we really need 2D shape and 3D shape.cpp?
Maybe not. Maybe it's up for you to decide. Now, let's go about making our shape. So basic. It's a class. Have I lost anyone? No? It's just a shape. That's all it is. We need our constructor. We need our destructor. Because we're going to be using virtual methods. Of course we are. And what we need, we're going to need to use any shared methods if they are shared between them. So it'll be get area, get perimeter, get volume. if required. We'll get into that in a second. Let's just do the inheritance part. Save. And I definitely have two shape.h's. I think I do. There it is. Caught you. Aha. LS. Get back here. Oh. Subble. Shape.cpp. Cool, we're back. So let's make the inheritance structure right now. So 2D shape, it's going to inherit from shape, of course. Make our class, colon, public, shape. Have I lost anyone yet? Yes.
Let's catch up later.
No, you won't. What's your question?
Why are you putting the shape next to public in the top row? I thought that public was exclusively reserved for between brackets.
Yes, in most cases it is. But when we're working with inheritance, this is how we denote that 2D shape inherits from shape. You have to have that public there, otherwise the compiler will throw an error and it gets angry. I don't know why. It just does. So when you inherit from something, use public beforehand. Let's continue work. Yes. Include? Yes, that's a good catch too. How else does it know that we're working with a shape? It doesn't. It has no idea. What the heck is a shape? Nick's idea of a shape is different from my idea of a shape. Maybe his shape is like this weird polygon and mine is a circle. You know, that could be different. This way we know that it's the shape.h on my computer. Don't you forget that header file. Because you probably will, and I've done it before, and it's a real pain. Fine, save that. Let's go to 3D shape class. And what do we do here? What does 3D shape inherit from? Yes, it inherits from shape. Shape, right there. But Darian, there's a problem here. What if I have a 3D shape and a 2D shape in the same file? Now I've included shape.h twice. How do I fix that? What did I talk about? Maybe once or twice last class that could fix this.
The header guards.
The header guards. So if we remember from last class, header guards are what we use to make it so that we don't include the same header file more than once. Because when we're working with our most derived versions of the class, square, circle, cube, and sphere, what's going to happen is now we've included, if we have them all in one file, we've now included 2D shape twice, 3D shape twice, and shape 4 times. The compiler is going to get very mad at that, and reasonably so. So what do we need? We need some header guards. So, if and def, and we're doing shape underscore h, define shape underscore h, and if shape underscore h with this commented out. This is just best practice, but it's not necessary, but it looks better. Okay. Can someone explain what this means? No one in the C class. Yes.
Means if you have defined shape underscore h, define shape underscore h.
There you go. That's exactly it. If not defined, define. That's it. It's right there. The answer is literally in front of you. So, let's do it for 2D shape and 3D shape. Yeah. If and def and 2D shape h. Actually, put another one there and define 2D at d shape h and if 2D shape. Nice. There we go. I actually purchased Sublime Text, by the way. I just haven't put my license in yet. Don't judge. Anyway, We also need this for 3D shape. And we're just going to breeze through this now. And we're going to use 3D shape H. This. Move this to the bottom. Have I lost anyone so far? Yes.
Should that be shape.h instead of 3D shape.h?
Should it be what?
The include.
Yes, that should be shape.h. That's a great save. I totally would have missed that. All right. Anyone else? You sure? Cool. Now we need some more header files. What's the next one? We've already worked with 2D shape. We've already worked with 3D shape. We've already worked with shape. Now we need some 2D shapes to make. So let's make this right here. Let's make a square. So we're going to do class. We've made a square. And this is going to inherit from. I almost just wrote the job away. We're not going to do that. From public 2D shape. We're going to have our header guards. And we're going to call this square H. Going to move this to the bottom. We're going to do this for circle too. This is exactly the same as it was before. Yes.
What is that value thing that it has when you say, when it gives you the default, if not find default?
If you're using forward declaration, you can use that value. Why? We're not using forward declaration, so don't worry about it right now. But you can use it if you do use forward declaration. Okay. Yes.
Do you need to include the 2D shape file?
Yes. Look at that. You're keeping aware of things while I'm not. 2D shape dot H. Now it works. In fact, let's actually just compile this. Actually, no, we don't have a main function. We can't compile it yet. We'll compile it in a second. Let's just finish fleshing out these. Let's make circle. So we're going to do the header guards first. Circle H. Got time. And class circle. And we're going to colon 2D shape. And we're going to include 2D shape.h. This is getting very repetitive. That's the point. We're just going to do one 3D shape. Oop. Define. And H. And class. And this inherits from 3D shape. Did I say what 3D shape is yet? I did. Okay, good. Ah, screw it. We only have one other 3D shape. Let's just make it real quick. Define sphere H class sphere. Good. Now we've defined all of our header files for all of our programs. This beautiful tree right here, it's laid out for us. Nice. Okay, yes.
Are you gonna fix your inheritance and includes on all those?
Eventually.
Okay.
Yes, I'm very sloppy with my includes right now. Mostly because we have a limited amount of time. And that's really about it, actually. And 3D shape. Yes.
I think there's 3 of them you left public out.
Ah. Too many keyboard shortcuts. Public. Public. I think. Yes, it does. Good. We have ours now. Yes.
So yeah.
What? Oh, yeah, yes. Good. We have our stuff. Nice. This is all we need for our tree. No more small mistakes, or one would argue those are large mistakes, because I'm flying through this. Now, what we need are our virtual methods, if we're going to do part B. So, I'm not going to go into this yet, because this is part of your assignment, and I only want to do so much of it. But we're going to write some of these as virtual methods inside shape, or 2D shape, or 3D shape. They don't all have to be in shape. In fact, not all of the methods are applicable to every single shape. So, you don't necessarily want to include a get volume for all of these. Or maybe you do. A 2D shape has a volume, doesn't it? Does it? Think about it. We'll look at your assignments and you hand them in. All right? And then this last part deals with FizzBuzz objects. It's going to take the area of each shape, and you're going to have to do FizzBuzz cool FizzBuzz things with it. Nice. Are there any questions about what I've gone over? No? Haven't lost anyone. Cool, I can't wait to lose people in these next few slides. So, let's talk about intro to pointers. That's right. For those who worked on the Gamma assignment, I'm very sorry that I gave you these pointers already, and I'm very sorry I don't have animations here, even though I really would like them. Do I seriously not have? Yeah, 5. So what happens with C++ is that when you're working by passing things into functions, you're doing something called passing by value, okay? So let's say, this is a pretty good example. Let's say someone here is studiously copying down every single character that I've put up here. I say that's silly because you get a lot more from what I'm saying than what's on the slides, but you could do that. This is the idea behind pass by value. You have copied down everything that's on this slide. But if you change what's on your own notes, it's not going to change what's up there. You physically made a copy, and that's yours. Nice. Now, the difference between that is you can also pass things by reference. So it's similar to passing an address. This is the easiest way to explain it. Let's say that I live, what's the address of University Crossing? I don't know. You all know where University Crossing is. Let's say I live at University Crossing. My house is University Crossing. I live there. It's a physical thing. But when I say, Dave, you should come over to my house, I'm not going to pass you a copy of my house. I'm going to say, here's the address of my house. It's University Crossing. And you're going to go to that address, and you're going to see what's there. Now, the thing with addresses, if I give you an address to University Crossing, and I change University Crossing, maybe I turn it into a McDonald's while you're not looking. You still have that address, but now you're going to go to a McDonald's when you go there. This is the idea behind pointers, is that you're passing an address, you are not passing a copy. So, if I pass something in to a function with a pointer attached to it, if we change the value inside that function, it's going to change it everywhere, all over the place. All right. This is the general idea behind pointers. Give me a sec. I need my dramatic effect. This will take like 5 seconds, I swear. I know we only have 10 minutes. Just want these back. 1. This one right here. 5 more seconds. Actually, give me 20 seconds. You can even put a timer to that if you want. Back here. What time am I at? Am I at 20 seconds yet? Oh my, thank God. Time is running out.
5, 4, 3, 2.
I'm plugging it back in. It's too late. We're good. So, let's talk about, let's get back here. But why? Why would you want to work with pointers? Why in the world would you want to work with addresses when you can just copy the damn thing over and call it a day? There are lots of reasons. One is performance. It's faster to just give someone your address than to give them your whole house. Imagine if you had to do that every time a friend came over. That'd be terrible. You can modify variables outside of their methods. This is great because you can send a variable to another method, and you can change it when you're out there. In addition, performance, some speed improvements, performance, it's all there. In fact, a lot of the time when you're working with these, the real reason to use pointers is for performance. It makes things really fast in a lot of ways. But why wouldn't you? Well, there's a possibility of unknowingly changing the variables you have inside functions. That's one. And two, that is so out of order. It can become difficult to manage pointers. And we're going to get into that more in the next class when we talk about unique pointers and shared pointers. But let's say that I give David my address. It's University Crossing. I changed it to McDonald's. He's like, you know what? I love McDonald's. This is great. And then I'm like, you know what? I'm going to change it to Chuck E. Cheese. He's like, you know, this is kind of weird. I'm not coming back to Darian's house. Then I tell him that it's going to be amazing. I tell him it's going to come back. He should come back the next week, and it's going to be the best place he's ever been. And then I just tear the place down. And then he goes there. And what happens? He gets a segmentation fault. For those in C, you know that this is a very common and very annoying error. For those who aren't in C, what happens is that if you give something an address, and that address is gone, you get this error called a segmentation fault. It's a non-descriptive error. It's incredibly annoying. And it doesn't tell you where your error is. It just tells you have one. In memory, this is called a memory error. You can find these all over the place if you're working with pointers, and they can be such a pain. I already passed in the assignment, but I passed in an assignment last semester, first semester of my sophomore year, that would throw a segmentation fault one every 20,000 runs. And I didn't know why. And if I passed it in and my teacher ran it and it got that segmentation fault, I would have got like a 50 in that assignment. So that didn't happen, luckily. But this is the issue with working with pointers. You can create these issues if you're not very, very, very careful with them. So just know you're playing with fire, but it's really fast fire. It's really cool. It's like that car, but it's got, you know, those huge jet engines on the sides, like bam. Okay. Any questions so far? No? Yes?
Why do we have a 1 in 20,000 chance of failing?
I don't know.
But
I ran.
Why would it work the other 19,999 times?
I don't know. I ran the program a million times. I wanted to stress test it. I had a script. It ran the program a million times, and I watched 500,000 seg faults or 50,000 seg faults. It was, or however many. I don't remember. I don't know. There were a lot of seg faults. Just like ding, 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 ding. I don't know why. That's the thing with memory errors. They're tough to debug. This is why when you're working with pointers, you have to be very careful. Because you can run into these where it can seg fault every so often. Now, my program is also...
Randomly though?
I don't know. If I knew, do you think I would have passed in a flawed assignment? I don't think so. No. Anyway, you have to be very careful when you're working with these because sometimes they can create unintended errors and you don't necessarily know why. There are tools to help with this, but they're imperfect, especially if you get an error that's esoteric like mine that happens once every 20,000 or so runs. So just make sure when you're working with pointers, you're very careful. Okay? That's all there is to it. It's the final slide. You are free to go unless there are any other questions. Have a great class. Great day. Great night. I don't even know what it is anymore. Good talk.
And the alpha assignment?
Yes.
Do
It's due before next class. Or if you want feedback before noon, Sunday before next class. Can't promise I'll be able to get you your feedback on Sunday next week, but you will need to get it in before that time.
okay. Is it true that beta is going twice as, or is due twice as much as alpha?
Here's how it works.
I mean, you did explain it before, and I think you said that.
That's sort of the idea. get alpha, call this number 1, then beta, and gamma, 1. Next week, beta, 2, gamma, 3, alpha 1. Pass it in. Alpha 2, beta 2, or 3, and gamma 4 or 5. That's how it works.
Do the 1, 2, 3, 4, and 5 correspond to weeks? Of like
Weeks
like
slash
levels of
difficulty. If you do only alpha assignments, you're going to get all the content in the class. If you do the beta assignments, you're going to get all the content in the class, and you're going to get more practice. If you do the gamma assignments, you're going to end up doing a little bit more than what's in the class. You're just going to be expected to do that work outside of class too. And you'll be doing the content much, much faster than anyone else. That is
okay,
correct.
so people on gamma right now are doing what alpha will be doing.
People who are on gamma right now just did pointers last week. Yeah, pointers and vectors.
Okay.
Or they tried to. One or the other.
Alright, so gamma is just more accelerated and will end up going past the scope of the class.
Yes.
Whereas alpha is
Exactly the scope of the class. Beta is just alpha but with a bit more practice. Oh, I'm still recording. Ah! Save.